It's just a Hey, Reese, how are you?
I'm good. How are you?
Good.
Good. I have one question.
Okay.
Let me go.
I need to make sure that I post all I have posted right now, like up in my work box, which I apologize for. I thought I had. Are you working on the domain and range and function, the 8 problem worksheet? Is that the one you're working on? It's got eight graphs on it.
I'm getting it out right now.
Okay, sorry.
Good.
I thought I had that up, but I did not.
Was it that warm up that you had us do yesterday?
Well, I've got that up. But I'm trying to load the one.
Oh, that okay. I see that.
That I think it says. I wish I had a different way to name that worksheet, but the website that I come from, it basically kind of gives it its own name, so I can't really overwrite it. Yeah. But I believe it says domain. I've got it on my one computer, but I don't have it on my math lab computer. So that's what I'm in the midst of trying to transfer now. I didn't realize it until I got here, so I apologize for that.
Okay. The sheet that you gave us yesterday says domain and range of graphs.
Okay. So, thank you very much.
You're welcome.
And maybe I'll probably get over in my drive and see that it was there the whole time, but I didn't see it when I pulled it up. But I do have everything else from. Yeah, that's not the one. I have one in there in my, but the other one.
Yeah.
I don't have. Because we did one earlier this semester, or I had one made for earlier this semester. Let's see.
Miss Sparks.
Yes, love.
Did you say that these graphs were going to be bonus on the test?
The real life graphs?
Yeah, the ones we are doing today for homework.
Yes, ma'am. They are going to be. And I can go over those again today as well. I found it, Reese.
Good.
At least I'm hoping I did. I'm going to go over here while that's loading and share. My screen. Oh, Samantha asked if I was muted. Can you hear me now, Samantha? Will somebody tell her sometimes you have to log off and log back in?
I think she just did that.
I think she just did that. Oh, okay. Is it still working for her or not working?
I don't know.
Samantha, can you hear me?
She just joined again.
Okay. Samantha, can you hear me now? Maybe if I mute and unmute. Is her volume turned up? Can somebody text her that?
I can.
Okay. Just tell her I might be quieter than the last video she watched or something like that, whatever she did last on her computer. So I don't know. Okay, Reese, is this the right one, honey? Does it look like y'all's graphs?
Yes. That's our homework.
Okay. Or is there another sheet that you have a question on, Reese?
It's like it's like how every how every input has one output. And I'm wondering, like, it's like how I see for number 3 was that it was like maybe it was on Monday. I see like several of them five, and I don't know if they need to
Okay.
Is that on the sheet we did yesterday in class?
Was it the warm-up one? Let me see if I can.
The domain range mapping guide.
Hey, Jen.
What's up, guys? I don't even know why I'm here.
I'm trying to find it, Reese. What does it say at the very top?
Okay, why you mute yourself? Domain range mapping guide.
Could, because I can barely hear you. So can you? Does it look anything like that?
No, ma'am.
Except for with. Have we done it in class?
I think we did this at home. Maybe like Tuesday, maybe.
Okay.
I think.
And could you type what it is? Could you type exactly what it is?
The top.
Because like Tuesday. The top of the next page, is that what someone's saying? So it's not that, right?
It's not that.
It's not that. Is it not the vertical line test either, right?
Mm-mm.
Reese, is it what we did in class yesterday?
Is it this?
Is it what?
You have questions on this one as well?
Well, no, it's just 1 and 2. Like for that one.
Yes, ma'am.
So can every X only have one Y? Like.
Yes. What basically the way I think of it, the easier way to think of it is no X can be repeated. So like here's -5, -1, 3, -1. This -1 is repeated. So that is not going to be a function.
Okay.
Okay.
Makes sense.
And so then when you're writing it, you want to write it from least to greatest.
Okay.
So now they're all accounted for. There were 4 ordered pairs, but 1 is repeated. So there's only 1 X in the domain. But here on number 2, you've got a 0, a 5, a -4, and a 9 for your domain. Oops. -4.
Just think of it a Miss Richardson way. Like you can't like your X twice.
Oh yeah. Oh, what's up, Alex?
Oh, that's so funny.
Welcome to the math lab.
I know.
Yeah. Oh, y'all are great. Okay.
Those graphs that we did yesterday just be bonus.
Yes. For tomorrow's test, because I just introduced it at the last of the class, they will be bonus. However, they are going to reappear when I test over the whole thing. So my suggestion is that y'all continue to work through those and don't lose that worksheet. Tomorrow they will be bonus, but later it will be expected knowledge. Does that make sense?
Yes, ma'am.
I don't ever expect you guys to know something. It's very much like the literal equations. Remember how all of that was a bonus on the chapter test because it was the very last thing that I taught?
Yeah.
That's usually how I do that stuff. But later on, we're probably going to have literal equations and functions as equations. As a matter of fact, we're going to have it next week.
So
Then
is this going to be a
second time? Tomorrow is a quiz. Next Friday is a quiz. But when we get back from fall break, it's going to be.
Will we check our graph?
How do you check the real graph stuff?
Yeah,
I can pull it up this morning. I can definitely pull that up this morning in math lab. Oh, Sophia, I just saw that you're at the daily grind. I'm jealous.
Sophia left.
But I am drinking my coffee. Huh? Hey, Daniel. How are you?
Good.
Oh, Sophia left.
Yep.
Oh, man. Well, she was at the daily grind. All right. So I'm going to, Reese, did that answer your question? One other thing that I kind of want to, something I was praying about actually this morning that I want to clarify why everybody is here. The difference, there's a few people that this has been a little confusing for, but I want to explain the difference. Let's take a look at number 3 and number 4. Number 3 is called a discrete graph. Nice handwriting, Miss Sparks. And number 4 is called a continuous graph. And a discrete graph is where there are dots all over the screen. And a continuous graph is where everything is connected. Now, granted, at the very ends of number 4, those holes are open, but it's still a continuous graph because what I want you guys to understand, because I know a lot of you are taking a look and getting these ordered pairs, like 1, 2, 3, 4. That first dot is -4, 0. And then the second one over here is -3, 2. And then we have 1, 3. And then we have 1, -6. And then we have 2. Sorry, I'm going into the other one. 5. So that is a finite. Now, y'all are going to love this. Everybody was talking about their brackets. There's Miss Sparks's. Not pretty. Just saying.
I want to see this.
1 and then 2.
It's better than mine, Miss Sparks. It's okay.
Oh, thank you. They're a little scary. Like I said, it's kind of like a deformed sideways bat. So I definitely have a domain that's repeated, or an object in the domain, and my domain is finite. It's there aren't any other points. What I want you to understand about this, because it's continuous all the way down like that, there are multiple points in between there. And that's why you have to write the range as a greater than or less than.
Miss Sparks?
Yes.
I was wondering if, we used to watch the video for homework too, especially on email.
Yeah, I think the video is like 5 minutes.
Yeah, it's like 5 minutes, 30 seconds. It's
Okay.
it's funny. The announcements come on at one point.
Yeah, I was going to say that I feel bad for the guy. His power source comes out, the announcements come on.
Yeah.
So it's definitely entertaining, but it's just a good reminder of domain and range. And I'm trying to reach out to you guys and make sure that you hear domain and range as many different ways as you can, because I feel like the struggle was hard yesterday.
This is awkward. My cat's jumping on my keyboard. Yeah, you can go outside.
The feedback is horrendous.
I know, it's so bad.
Somebody
Noise.
Jet, Miss Sparks.
Why won't it let me unmute her? No. What?
Jet, Miss Sparks. Jet, Miss Sparks.
That's hilarious.
Miss Sparks is like going crazy.
Oh, I can permanently block her. Is she mad?
I don't know. I don't think so. Miss Sparks, I'm sorry. There's Jet though.
Oh, it won't let me unmute her, darn it.
Everybody unmuted except for me, Kennedy, and Reese. And Jet.
And me. What are you talking about, Daniel?
Okay, can y'all hear me now?
Yeah.
There we go. Okay.
Jet muted me, Miss Sparks.
I know. I went back over to find out what happened. I could tell something happened. But at least the feedback was better for a minute.
Oh, that's awkward.
All right. Do you all want me to continue going through the warm-up or go over the worksheet?
Oh, my ears. Hey, guys, I'm gonna leave. See ya.
Bye, Jet. Alright, Miss Sparks, I'm gonna go watch the video.
Okay. Are you good on the worksheet, Daniel?
Oh, yes, ma'am. That made sense for me.
Oh, okay. Good. I'm glad. Well, you have a blessed day.
Thank you.
For the quiz, do we need to know the different notations and how to write domains and range graphs?
No, you just have to be able to do one. I don't care which one. I just introduced a new way just because some people were having a difficult time with the greater than or less than.
I can't remember.
Which parenthesis went with which?
Yeah.
Is that what you asked?
Yeah.
Okay. The hard bracket. So let me do one this way. The hard bracket. And if this is not how you want to do it, then no one has to kind of pay attention to this part. But okay, we're going to look at number 4 as a for instance. 1, 2, 3. Okay, so -3 would be less than, okay, because it's open. It's just less than. Oops. I'm going to write it this way, and then I'm going to write it the other way so that you can kind of see what I mean. It's just less than x, which is less than 2. Okay, so that's how we would write it the way we are now with no equal than sign. Does that make sense?
Yes, ma'am.
How we're doing it now?
Yes, ma'am.
And the soft bracket is when there are no less than or equal to. Like, say if one of them were colored in, or let's just pretend both of them were colored in for just a minute, okay? They would be hard brackets.
Okay.
That means it's included.
If it has
This
like
means not included. It has no not included, included.
Okay.
All right, say that again.
So if it has
Because I'm getting feedback again.
circles or no filled in circles, is that less than or equal to also?
This here, oh yes, that's less than or equal to. So this one down here would look like this. This is this one, and this is this one. Does that make sense?
Yes, ma'am.
Or no? All right, now let's just pretend for a minute 1 is not included and 1 is. So the one not included would be like this, and the one included would be like that. But it doesn't make any difference to me how you do it. You're welcome. All right, I do want to get a chance to go to the worksheet. Wait a minute. Is there any more questions like on the warm up or whatever? Can I, oh, I just clicked back over. Amanda, can you see my work now?
Could you go over number 2?
Yes. Can somebody ask Amanda if she can see my work?
I will.
Because she said she couldn't see my work. So I didn't know if in all that craziness something happened.
You said no, I can't.
Number 2. Okay. She may have to log off. Tell her to log off and then log back in and see if that helps. Thank you. Number 2, for the domain, left that an X is, because that circle at the top is not, it's not an arrow, so it doesn't mean that it's going into infinity. It's actually it's an open circle. So that point is 1, 2, it is -2, and then 4. So that's this point on this side, and this point on this side is 2, 4. But they're open circles. So that is not going to be included in the domain. So the domain is going to be -2 is less than X, which is less than 2. And if you were writing it that other way, it would be -2, 2. And the range, the lowest point that the range goes is way down here. So it's going to be 0 is less than X, and the highest point is all the way up here. But actually 0 is less than or equal to, because it's included, which is less than 4. Because it goes all the way up here, but not included. So this would be written like this.
Don't have like any markings on them. I was saying this in ones with the squares. Those are both included.
Oh, wow. The feedback is so bad. whoever just asked me a question, I'm going to switch back over to the
Miss Sparks, I can't hear you.
can't see anything. So I don't know. Maybe I can. Is everybody else seeing stuff?
I am.
I can't see you.
You can't see me or my work.
No, ma'am.
I
And
think.
someone
Okay. I think what I'm.
Someone's blocking me.
Uh,
I was trying to figure out how to get on here because it keeps telling me that someone blocked me.
Okay. Okay. I don't know what I'm gonna have to do. Squares. Let's see. Oh, I see what you're saying. Those are the ones that are included. Yes. So if it's circled and filled in, Samantha, it is included. If it's open, it's not. But the key thing to remember about it is, and I think what I may have to do, y'all, is actually close all of Math Lab out and just restart it because I don't know what happened when Jet came on and did all of that. So I don't know. Did anybody block Mary Faith that you know of, or do it accidentally, or does anybody know where I can unblock people?
So what you do, I don't know how to unblock, but I know how you would block.
Okay.
So it might be the same.
How do I?
So if you click on
okay.
file, there's
Amanda says she thinks she might have done it accidentally. So the other thing that I could try to do, Mary Faith, is you're not seeing the worksheet. Is that correct?
Now I do.
Okay. Is there anybody else who's not seeing the worksheet or what I'm writing? Amanda, you can't see the worksheet? Did anybody block Amanda accidentally? I think what I'm going to do is try to reshare and see if that helps. Can you see it now, Amanda? Oh, I don't know. I don't know what to do. Is there anybody else who can't see it? Amanda, I may have to send you the answers. Sorry, baby. And if I need to later, I'll do a separate Google Hangout with you since you didn't get to see it. And hopefully it'll work there. But is everybody okay with me continuing to just work through this worksheet? Will that be helpful? Oh, you're welcome, Amanda. I'm sorry that you couldn't see it. I don't know if you can hear me okay, which it seems like you can. If you want to hear me discuss it, I'll try to make it where if you have your worksheet in front of you, I'll try to make it clear. I don't know how you want to do it, but we can do that. On this second one, to kind of finish it out, this second one would pass the vertical line test, meaning that a vertical line could be put on this graph all the way through and never hit this graph more than once anywhere. Run through 2x points more than once anywhere. So it is a function. The domain for number one, the top or the far left part would be -4. So -4, and it is colored in.
I put
So
all
it's
real
less
numbers.
than or equal to X.
I put all real numbers.
Okay. And I'm glad that we went back to that. See, on this one, that's not an arrow at the top. That's a closed in circle or a closed in square. If this were an arrow, it would be all real numbers, but it is not an arrow. It's a closed dot. So one of the first things that you're going to want to ask yourself tomorrow is the end behavior. This is really important, and this will move on ahead of you in other math. What you're looking at is the end behavior of the graph, and then what is the behavior in the middle. So the end behavior on this are two closed dots. And then is less than or equal to 5. That's the furthest right. No, 2. My apologies. 2. I was looking at the range.
I still don't really understand.
The furthest right that it goes.
I still don't really understand.
Okay. Okay. Thank you for your honesty. So what we're doing, what is the furthest, what's this point right here? What's the coordinate?
The X or Y? The X or Y?
Both. The
Okay.
ordered pair, the coordinate.
Okay. -4, -4.
What is it?
-4.
Okay. So for the domain, what are we working with? What are we working with for the domain?
-4.
X or Y?
-4. Oh, X.
Right, and because we're working with the X.
Oh, X.
Okay, so this is the X, and this is the Y. Would you agree with me that this graph doesn't go any further left than -4?
Yeah.
Because we're just dealing with left and right now.
Yeah.
Okay. Now, what is this? What is this point all the way over here to the right?
Like
What is the ordered pair?
Okay. Like the coordinate?
Yes, ma'am.
Okay.
I'm sorry?
2 and 5.
I couldn't hear you.
2 and 5.
2 and 5, is that what you said?
Yeah.
2 and 5 is correct. Would you agree with me that this graph doesn't go any further right on the x-axis? That's the furthest positive point or furthest point to the right on this graph for the x. Is there any other x's that are further past that? Okay, so that is my boundaries for my domain. Everything else in between -4 and 2 is a possibility for the x. And because the circles are enclosed, it means it includes that point.
Okay.
Okay, does that help?
Mm-hmm.
Okay, so for the range, we're talking about up and down. So the lowest point on this graph is what?
-4.
What's the lowest point?
-4.
-4 is less, and it's a closed circle, so it's going to be less than or equal to y, because we're dealing with the y. And then what's the highest point on this graph?
5.
So it's going to be less than or equal to 5. And it's less than or equal to, it includes the equal to part because it's a closed circle.
Okay.
If it was an open circle, it would just be less than because it wouldn't include it.
So it is a function?
So it is a function because it passes that vertical line test.
Okay.
So yes, it's a function.
Okay.
All right. So number 3. What is the furthest left point? Or what's the furthest point? Yeah, left, and it actually happens to be the top point. But what is this coordinate right here? Because I don't think there's a coordinate that goes beyond that. What is that coordinate?
-3 and 5. -3 and 5.
-3, 5. Is there anything further left than that point?
No.
Okay, so that's going to be my furthest left point. And it's closed in, so it's going to be less than or equal to x. All right, and the furthest point to the right is 0, -3. So, and it's open, so it's not included. So it's just a less than. So somebody was asking earlier about the bracket notation. This is a good one to illustrate that on. It would be a hard bracket to include the 3 and a soft bracket to not include the 0. Now the range is our up-down part. The very bottom point of this graph, the lowest point is down here. And it's not included because it's a circle, open circle. So it's -3 is just less than y. And the very highest point, because we're dealing with top and bottom, and it's a 5 and it's closed in, so it's less than or equal to 5.
Okay.
And this is a function because it would pass the vertical line test.
Do you have to put
Now,
the
number
equal sign?
4.
Do you have to put the equal sign?
On which one, honey?
The range for number 3.
On the range?
The range for number 3.
At the less than or equal sign to the 5? Yes, because it's closed in up here. This is the top point, and that is closed in.
Okay.
So it's interesting. This is a really good illustration because on our domain, the furthest left point was the one that was less than or equal to. But for our range, that higher point was the one that was less than or equal to because it's closed in there. So I can't really tell voices too well, but whoever asked that question, that was really good because we got to really highlight kind of the difference of how those less than or equal to signs get highlighted in the domain and range differently because of how they, play a part in it. So great question. Is that clear to everybody? Because this was a good graph to illustrate that on.
Yes, ma'am.
Y'all are asking such good questions this morning in Math Lab. I'm really proud of you guys.
Miss Sparks. Miss Sparks.
Yes.
Why did you color in the second graph?
Why did I color it in? I was demonstrating the vertical line test.
I didn't know if that was like in the math packet that we did every summer where you had to color in half of the graph.
Oh, I understand what you're saying, but no, ma'am, it wasn't. I'm sorry. It was just the vertical line test. Oh, you're welcome. Okay, number 4, the domain. So the furthest left that it goes is -1. And then the furthest right that it's going to go is going to be this line right here. And I'm going to erase that, but I just kind of want to draw it on there to illustrate. Well, that's going to be a 3. But that 3 is an open circle up here and at the bottom. Okay? So it's -1 is going to be less than or equal to because it's closed in here. No, it's not a circle or anything, but it curves around. So it definitely is included because if it wasn't included, and there can be holes in continuous graphs, believe it or not, but on this particular one, but they would show up much like that circle at the top. But it is not, it is colored in, so it is definitely included. But on the far right side, it is not included at this 3. So it's going to be a less than. Not included. So it's -1 is less than or equal to x is less than 3. This is left and right. That was our domain. Now, top to bottom. Our very top point is up here. Our very bottom point is down here. Both of them are open circles. So that means they would not be included. So that's going to be -4 is less than y is less than 4. But everything else along here, all the rest of the up and down, the y coordinates are a possibility in between those. And this would not, I'm coloring it in kind of again, would not pass the vertical line test. So it is not a function. And number 5, for the domain, the farthest left that we go is -2. The farthest right that we go, and it is closed in over there, so it's going to be less than or equal to x. The far right position, the 4, is open. So it's just going to be less than because it is not included in that portion of the domain. Now, the bottom point that we have for our range is down here. It is not included, and it's a -4. So it's not included, so it's just a less than. And the very top point is a 3, and it's not included. It's an open circle, the bottom. This is the lowest point on the graph, yes? And it's an open circle. So it's just a less than, not a less than or equal to. If it was a closed circle, it would be included, right?
Oh, okay.
That's the difference between an open and a closed.
Oh, okay.
But over here, it is included, even though it's not like a dot on the graph, it still runs smoothly through it. So that's why in the domain up here, it is included. This also would not pass a vertical line test. So it is not a function. All right. The domain. What is the furthest left point on this graph for number 6? What's the furthest left?
-4. Oh, yeah, sorry, wrong.
Anyone?
-4. Yeah. Yeah, sorry, wrong.
Yeah, number 6. Number 6. Which one is it?
0.
What is it? Furthest left.
0.
0. Good job. All right. What's the first? And is it included or not included?
Included.
Included.
Yes. Good job. So it's less than or equal to x. And the furthest right is what?
4.
4.
4. And is it included or not included?
Not included. Not included.
Good. Is this making more sense to everyone, or is it still some of you clear as
Yes.
mud?
A little bit.
Yes.
Okay,
A
good.
little bit.
I was going to say some of you are answering well, and don't be afraid to answer or ask questions for clarification. Okay, the bottom lowest point on this graph is what? Going from top to bottom, what's the lowest point on number 6?
Neg -2. -2.
-2. Good job. Is it included or not included?
Not included. Not included.
Not included. Good job. All right, so we got -2 is less than y. And what's the highest point on this graph?
2.
2. So is it included or not included?
Not included. Not included.
Not included because the circle is open. And would this one pass the vertical line test?
No.
No.
No, it would not. So it is not a function. All right, number 7. What is the furthest left point this way
-4.
on this graph? What's the one that goes
-4.
-4? Is it included or not included?
Included.
Included. So it's less than or equal to x. And what's the furthest right?
1.
And is it included or not included?
Included.
So it's less than or equal to 1. All right. Now, going from top to bottom, what's the lowest point on this graph?
-2.
-2. And is it included or not included? Included. So less than or equal to y. And what's the highest point on this graph? 1. And it's included. And this one would pass the vertical line test. So it is a function. Okay. The furthest left point on number 8.
0.
0. Good job. And is it included or not included?
Included.
Included. And the furthest right point?
Not included.
It's not included. Good job. And its value is what?
5.
5. Good job. And the lowest point on this graph, going from bottom to top, what is it? -1. And is it included or not included?
Not included.
The circle is open, so it is not included. Good job. And then y. And the highest point on this graph is what?
4, and it is included.
4, and it is included. Good job. And this one, would it pass the vertical line test?
Yes.
Good job. It would.
Now I understand.
Did that help? Okay, good. It just takes a lot of practice on this. I mean, you know, it took a lot of practice for me to really grasp it. And you know, I mean, I can obviously make more worksheets, but I know, y'all hate doing the worksheets, but they do help a lot. Any other questions for you guys? Anything? I feel so bad for Amanda.
But could we do the graphs like in class or another math lab soon?
The real life graphs?
Yes, ma'am.
We can look at some of those if you want to.
Yes, please. Some of those are pretty difficult.
Okay. Let me see. Are you talking about those?
Yes, ma'am. Yes.
Okay. Hold on just one second. I'm going to quit sharing for just a second because I've got to bring something else up. And it'll take me a minute to get there, and I just don't want to annoy you guys. I haven't gone anywhere, I promise. Do you want to work on the homework part or even what we worked on in class yesterday?
I don't think
A little bit of both.
Yeah, we kind of started it in class, and then we're supposed to finish it today.
Is Courtney Carmichael still here with us? Is she here? Oh, no, she left. This was a question she had too. Is there anybody on here that shares a class with Courtney that could tell her what we're going over, maybe in the Google Classroom?
I do.
Okay. Would you mind sharing with her that we're actually going over the real world graphs? Because I think she had a question about them too, or what the worksheet looked like. I can't remember.
Yeah.
Thank you.
Yeah.
All right. So we started this in class yesterday. And then the homework part, there was that piece of it too. But what we went over in class yesterday, just to make sure that you have everything of that, let's go through that. Did you get this part? I actually talked through this a little bit in class about the roller coaster, and I kind of compared it to Goliath.
And the matching graphs on the next page. Everything else is the homework.
Okay. So Chase is speeding on a highway and gets stopped by a police officer.
Miss Stokes, can you go?
Say what? The feedback is so bad. Can I explain number 2
No, can you start at
from
number
yesterday's class?
No, can you start at number 2?
Start at number 2. Oh, okay. Here, in a single day, it snowed lightly during the morning, then heavily.
You've done how to identify, like how you graph it, I guess. Okay, well, everybody's could look slightly different. This is just an example of what it looked like. Like I had somebody, their snowfall looked slightly different, but it still represented the fact that the snowfall got heavier at the end of, toward the day. So what you're looking at is it snowed lightly. It snowed lightly at first. So your snowfall, so the higher you would go this way is the more the snowfall, right? Oh,
so
okay.
it's snowing lightly, but they're in this particular one, they're kind of projecting that the snowfall is going to get heavier and then get really heavy.
Okay.
As the day progresses. Some people could have actually, if it snowed lightly, it doesn't say that it got heavier. It just says it got heavier in the rest of the day. So yours could have looked like this. You see what I'm saying? It wouldn't have to be, exactly like that. How are you seeing it? Do you know what I'm saying? It would not have to be exactly like this particular one. What you're trying to do is make a representation of what happens.
Okay.
And you want it to be, all right? Okay, so, and then this painting thing where we talked about yesterday, see, it takes that dip
and then it starts to go up because it's going to actually, over time, get more valuable for twice what she paid for it. So what you really are looking at is you want this. We don't really have any numbers along here. So we're just projecting that if this right here is where the value started, you would want this distance and the distance from here to wherever this is to be about the same. Like, you know, because if it doubled, so, you know, over time, so you see what I'm saying? That's exactly what you would want to have happen. There are no numbers. So basically you're just kind of projecting, but you want to project every little dip that's kind of described in the graph. So like on this basketball one, this is the distance from the ground. So this is it being dropped out the window. So you're kind of picturing it. And then it bounces back up to about half the way. And then each time it does that thing. So you can almost picture a ball bouncing. Does that make sense?
Mm-hmm.
So this is just like a graphical picture of things that you're describing. So it's supposed to be where you're able to interpret a graph and you're able to draw a graph. So Jace is speeding on a highway. And I think I would have actually done this one a little differently. But okay, so but he's speeding. So it kind of shows him taking, I might have actually showed him taking off. Like, okay, he's going really, really fast. You know? He starts off going really, really fast, then he gets
really fast,
stopped
really
by that
fast,
officer.
like it went up and then down and then straight across.
Yeah. See, I know, like that, like you did this first.
Yeah, except it just kind of met at a point. I know I did that part wrong.
Okay. Okay. So then he stops by the officer. This is him chatting with the officer. And then he takes back off again. And he goes, he's not going as fast this time. So I think I probably would have showed him taking off too. But that's just how I would have seen it. This graph just shows him speeding right off the bat. But what I'm trying to tell you guys is that your graph might look slightly different. Okay, Carlos is a running back on his football team. He ran the same number of yards in each of the first 6 games. So you're kind of seeing where he's taken off, and then he got hurt. See, I would have probably shown straight line. I think I talked about that class. What?
But didn't it just drop off? Like he couldn't play anymore after he was injured? So shouldn't it be like a straight line of him doing the same number of yards?
Yes, that's a really. After he did not play for the rest of the season due to an injury, so graph the games on the X-axis and total yards for the season. So he didn't get yards taken away from him. They would have just stayed steady for that. So like, okay, let's say up here he had 300 yards that he ran for the whole season. Those didn't go away, so we're not asking for an average. That didn't change.
I understand.
Okay. I know that could be a little confusing, but that was a really good question.
This graph was hard for me.
So Alice tried. I'm sorry.
Okay.
Did you have a question? I'm sorry. All right. Alice drives a school bus. On her morning route, she stops at every block to let students on. graph time on the x-axis. Okay, she stops at every block. Okay, graph time on the x-axis and the total distance the bus drives on the y. So this is Alice taking off here, and then this is a stop, and then she drives, or this is the stop, then she drives on, then this is a stop, then she drives on, this is a stop, you know, because she has to. And so this is just kind of a stepping stone because it's actually showing her stopping. And, you know, to be honest with you, I might have made the stops a little shorter in the distance, you know, because I'm kind of thinking, I don't know, maybe this is kind of indicating that it takes her the same, she stays at each stop almost the same amount of time it takes her to drive to each block. You might not have shown it that way, and that's okay. You know, you might show it that she's, you know, and you might show it that it takes her longer to drive than it does to stop. Ray started his workout by running on the treadmill. His heart rate rapidly increased and remained high during his run. So this is the heart rate. So it's increasing as he's running. This is his heart rate staying steady. Then he starts lifting weights. And probably what's happening as he walks over to pick up his weights or do his exercise, it's kind of dropping a little bit. Now he's lifting weights and he's peaked. And now he's moving to the different exercise. So he's going down. His heart rate is coming down a little bit. Then he goes back up. And then that would be the same over time as he goes from each different exercise. And then we did Mason, Carrie, and Luke in class. So now sketch the following graphs. The number of customers at a restaurant depends upon the time of day. Graph time on the x-axis and the number of customers on the y-axis. Y'all, this could have looked very different. Like if this, you know, perhaps, you know, they open and they get busier and busier. And then, you know, at a certain point, like 10 o'clock. Okay, well, now all of a sudden at 11 o'clock, people start coming in for late breakfast, early lunch. And then that probably goes on to like probably 1 o'clock. And then it stays steady. And then probably from 1 o'clock to about 5 o'clock, it stays steady. And then from 5 to 7, they get really, really busy. And then they probably steady out at 7.
It really just depends on the restaurant.
It does depend upon the restaurant. And so obviously there's not a complete clear right or wrong answer on this. You know, let's say, you know, some restaurants actually might stay steady the whole day. Some actually might go like this and go like that. Like they're just super busy. You know, Chick-fil-A probably looks straight up and down because I don't think I've ever been to a Chick-fil-A drive-through when that thing wasn't crammed. So theirs probably looks like this. Or, you know, it's like I think sometimes before they open, it might actually start way up here. There's like people before they ever open. So it, you know, like I say, there's not a right or wrong on that particular one. It really would depend upon the restaurant. A pitcher pitches a ball to a hitter. The ball is hit towards center field, hits the center field fence, then drops to the ground. Graph time on the x-axis and the height of the ball on the y-axis. So the pitcher pitches a ball to a hitter. So it comes out of the pitcher's hand. This is where the baseball player is knocking it out. So it goes up in the air. This is where it hits the fence, drops to the ground.
Is it okay if you use more straight lines instead of curved lines?
Absolutely. Absolutely.
So mine's essentially the same, just with a straight line.
That's fine. Mine probably would have been actually. I think I'm more of a jagged line drawer.
But like, yeah, it's straight and goes up and then comes straight back down. So.
Oh, that's fine. So
that's fine.
So more like.
Yeah, like that.
Okay. You know what? That's probably how. That's probably how what mine would have been too. A plant grows quickly at first, remains at a constant height during a dry spell, then grows at a steady pace. Graph time on the x-axis and the height of the plant on the y-axis. So what we're seeing is this plant growing really, really quickly, right? And then here's that steady pace. Or then here, I'm sorry, the constant rate, because it's a flat line. And then here's the steady pace. And actually, yours could have been more, something like that. Everybody's can look a little different. This is not an exact science because this is your own personal interpretation. What I'm looking for is, can I see the dips and the rises in the graph based on the description itself? Does that make sense?
Yeah.
The value of a car depreciates quickly in the first 2 years. I talked about this in class, definitely. Then depreciates at a steadier rate over time, which is very true. Graph time on the x-axis and the value of the car on the y-axis. So this is you driving your new car off the lot. And in all honesty, it dips way down. And then is a little more gradual over time. So, but what I'm looking for, see, I'm like, I would be even slightly different than the person who actually drew this the first time. So, like I say, as long as I can see that you understand that depreciate means to go down and that steadier rates are either like a constant rate is going to be a flat line, an increase is going to be a line that goes up, and a decrease is going to be a line that goes down. So as long as I'm seeing that on the graph, I'm not, it just needs to look at like that. Okay, so an oven is set for 425. And as we all know, when we set an oven, it takes a minute for it to heat up. A pizza is then baked in the oven, so it's going to be baked at that 425. So the oven actually reaches its correct temperature, and then you would turn the oven off. So this graph here shows the oven preheating here. Here's the pizza cooking, and now we've turned that oven off so it'll cool down. Does that make sense? Are these making more sense now that we're talking about and seeing them?
Yeah.
Okay, Sarah went up an escalator. So that's going to be obviously a line that goes up, then took the stairs back down. So basically this is a pretty easy one. So you're just looking going straight up and then coming back down. All right, now this is a little more on this back page, a little more like how the quiz is going to be tomorrow, where you're going to have to pick one or the other. So Jonah took a ride on a Ferris wheel. Which graph best represents his distance from the ground? And obviously, as you know, a Ferris wheel just goes in a circle. So as he's going around, he's going to look more like he's going up and down and up and down, right? Did you all pick A?
I said B because on a Ferris wheel, you go closer to the ground and then back up.
Right. So you guessed B?
I was drawing like his path. So if you start at the top and then get close to the ground, that one way down instead of coming right back all the way up. I didn't know it meant like one full rotation.
Oh, I got you. So I got you. So you picked B?
Yes, ma'am.
Okay. Well, you know what? If you were to make a notation of that, I would totally see that. But I think they were talking about here is where like when this is where you get on and get off, and this is maximum height when he's at the very top looking at everything. And then as he's down, but I kind of see what you're saying.
Okay, I understand this.
Okay. That's good though.
That's good though.
We need to talk these things through because I see what you're saying. Because I feel like I kind of felt that way on number 8 when I was looking at a plane pulls up to a gate and lets its passenger off. Which graph best represents the speed of the plane as it approaches the gate? You know, to me, I was thinking to myself, whenever I've ridden on a plane, when it landed, it seemed like a pretty steady pace to the gate to me. But I guess this is with them picking B, this is that approach to the gate and when they come to that final stop. But when you hit the runway after they put the brakes on and they're rolling down, you are going kind of at a steady pace, but it wouldn't be like he wouldn't just, you know, to a stop. So B is the better one, but I did feel like when I am in a plane, it's kind of a steady pace, but I guess it's a steady, slow pace as he's approaching it. All right. This one, it was funny. I was working with a student yesterday on this one, and I totally got where they were coming from. But what you have to think of is, where is Frank starting from? Is he starting away from the equator, or is he starting at the equator? If he's in Japan, is he above or below the equator? And so he would start above the equator because Japan is above the equator, right?
Oh.
So that's why. So he's starting in Japan.
If you don't understand geography, this question is hard.
Yes. You might. Yeah, I was going to say, you're starting in Japan, which is above the equator. Australia is below the equator.
I guess that
in
makes
order
sense
to
because
get there, you're going to have to approach the equator, and then you would pass it again. So he would be going, B would be the right one. This would be like if you started at Ecuador and you flew to New York and then you flew back to Ecuador, right? Because Ecuador, the reason why the name of it is Ecuador is because it's at the equator, right?
Oh, I didn't even think about that.
Yeah. Cool stuff. Like somebody said, the geography lesson right here in math.
Oh, great. Mr.
Sickley would be so happy.
Geography doesn't make me very happy.
I know. It can be a tough subject, but it does help when you study history later on. You'll be like, yeah, I remember where that is, sort of. Kiera walked up a hill at a steady pace, then ran down the hill. Which graph best represents her speed?
I totally looked at this, like, I totally didn't read the thing on the y-axis.
Oh, okay.
Which is why I picked B. I was thinking you're ascending the hill slowly and ran down. I didn't notice that it said speed.
Oh, okay. More of a distance thing.
Yeah, I was thinking distance.
Why is it A?
Because she walked up a hill at a steady pace. So, but I see exactly what y'all are saying, because you're actually thinking, okay, she's going up a hill. So you're thinking distance, or like, what is her incline? So, and that's the whole point of doing some of these things. You got to try to make sure, because what y'all are picturing is her walking up this hill. Okay. Picturing her walking up the hill. That is what her motion is. But we're looking at the speed, and it's a steady pace. So the speed is steady. Okay. And then, but so that there was trickery in that question, wasn't there? There really was. So, you know, I totally get that one. that one messed me up too. When I first did it, I totally was right there with y'all on the graph B. And then I was like, no, 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 no. So you really have to read those. I don't think anything on the quiz is that, or the final test after fall break is that tricky. All right, let's take a look at this last one. Okay, Carrie was describe a real life situation that would create the graph to the right. Include labels on the X and Y axis. Okay, this could be anything. This could be anything that you all wanted it to be. This could be running. This could be whatever you wanted it to be. Exercising, a bicycle, a car, a roller coaster, you know, getting stuck. It could be anything that you wanted it to be. I don't know. Carrie was spending money at a steady rate, but then stopped shopping for a while. Then Carrie started a babysitting job and saved all her earnings. So tell me some stuff. If y'all already done this, if anyone has done this, tell me what you said.
Okay, so I was tired, and I decided to make mine about giraffe sales.
Okay, I love that.
Martin sold giraffes. For the first year, giraffe sales dropped. The second year, they remained the same. And after that, giraffe sales skyrocketed.
Yay! I love that. So which what did you label this bottom at?
The bottom I said was, where'd this go? Time, and the y-axis was giraffe sales.
Okay, so it was time, but this
say profit.
Giraffe sales. Very creative. I love that. Giraffe sales. Love that. That's perfect.
Thank you.
So y'all can create anything.
So to study for the quiz, should we just rework some of our warm-up problems?
Yes, that's exactly what I would do.
I thought that sheet, didn't you say that one was most close to the quiz?
Yes.
Or, yes. Okay, I'll leave that one out then.
Yeah, I would. That's an excellent way to study for sure.
Like last time I reworked the study guide because you said that one was harder.
Yes. Didn't you think it was?
It was a lot harder. I'll do the warm up then this time.
Yeah, the warm up is most. Yeah, I'm sorry. I'm sorry. To see if anybody else had any other questions. Does anybody else have any other questions? And most definitely the warm up. If you can work through that warm up, you will be really, really good for the test or the quiz. I'm sorry, the quiz tomorrow. And the video, like I say, the poor guy, the announcements come on while he's talking, but he does a really good job of going over domain and range. If you all need that, also the very good review on that. There's a ton of videos out there on domain and range. For support on that.
Are there any questions to answer on that one?
I'm sorry. No, there aren't. I think it's no. Let's see. No, I just make a couple of comments. There's no. It'll stop. It looks like there's a question, but I'm just making comments because he labels the domain range on one place a little bit differently than we do, and I just want to make sure that you all understand that either way is fine.
Okay.
But it's no questions. It appears as if there are, but it's not. It's just me making a comment.
All right. Thank you.
Thank you. Great questions during Math Lab. You did an awesome job. And something else that I do want to clarify, the real world graphs, I think that's on the assignment sheet. And I want you guys to know that I think I said like your world graph worksheet. I put both of those together. They're stapled together with the notes. So when you're looking at the assignment, that's what it's referring to. Turn in both when you turn it in.
Okay.
So any other question?
Not that I can think of.
Okay, well, y'all have been awesome. If they come up during the day or you have any questions, please feel free to email me. Mackenzie does have a doctor appointment later on, but I'll have my phone with me so I can do my best to answer. But I may, if you have a question where I have to answer it, I may have to wait till I get back home and send something to you as an answer. But I'll do my very best to answer even while I'm out. All right. Well, y'all have a blessed day. I appreciate everyone coming. Take care.
Thank you.
Welcome.